Hello, everyone. So in this video, we are gonna explore another MATHCOUNTS problem. So this was a number 10 on a team run. So let's get started. So it says Nala draws a triangle ABC and randomly chooses a real number A between 0 to 1. And then she picks a point P on the side AB such that the ratio of PB to PA is A. And point Q is also chosen on AC such that the area of the triangle APQ is the half of the area of the triangle ABC. So what is the probability that QC divided by QA is lesser than or equal to 1/4? Okay, so it is already challenging to understand what's going on, especially without having a diagram. So it doesn't really tell us what kind of triangle, but to make it a bit easier, I will use a right triangle. Okay, so which doesn't matter if you want to use just a acute angle triangle, but for the sake of simplicity, we are going to use a right triangle. So let's say this is the triangle I have. And also, if you do have some better ways and other approaches, so share with me so we can kind of see some other ways as well. But this is going to be a bit longer. So let's say this is A, okay, and then this is B, and then this is C, okay? And there is a point like P on AB such that PB divided by PA. So we are going to choose something, let's say this point as P. It doesn't really matter where you choose, but I'm going to assume somewhere right there. So you could choose right there or anything between A to B. And PB divided by PA is A. So let's keep that in mind. So PB over PA. A is A over 1. Okay. And there is another point Q that is also chosen on AC. And then when you do so, the area of the triangle APQ should be half of the area of the ABC. Maybe kind of to see kind of halfway of that picture. It doesn't have to be exact this location or this location, but I'm gonna just choose these just to see how things are gonna look like. Okay, so we got that. And then if I connect these two, the area of this triangle has to be half of the area of the ABC. Okay, this is already challenging because we have no idea about how, like, where this is located or where this is located. Only thing is this area and this area should be same. And then we want the ratio of QC divided by QA should be lesser than or equal to 1/4. So let's use whatever we have. Okay, so PB, if I say this is A, and then PA will be 1 unit. So since we are looking for ratios as a probability, the actual number doesn't really matter. So you can choose A and 1, and I don't know, 2A and 2, whatever, but I just choose 1 and A. And okay, so we are dealing with area. Maybe it's good to write the area of the triangle APQ. So let's go with that first. So the APQ. So, if you want to find the area of this triangle, you need a base and height, and then there is no sides given except AP. So, which is why I need to use that as my base. But at the same time, the height for that base is not really in that triangle because based on my drawing, this angle is obtuse. So this is the acute. So my height should be outside. So it could be something like this, right? So I'm gonna say this is H, and this is 90 degrees. Okay, so to find the area, so let's go ahead and write that. So that will give us AP times HQ. And then we do multiply this by 1/2. Okay, this is the area, but at the same time, it doesn't really help us because we have no idea about HQ and we know AP, but that we don't know the area either. We just know is the whole thing is twice as much. So which is why I need to relate this HQ somehow into my other information that we are given, right? And also we know that QC divided by QA should be lesser than 1/4. So let's kind of start with it as well. So QC over QA. I'm gonna choose this ratio is, let's say P. Okay, And but how this is gonna be useful, all right? So QA is given, QA is okay. Anyway, so let's combine them. So if I want to get rid of this HQ from my equation, I should relate this side into some of the other sides. So there is BC, like this is a right triangle, and then ABC and HQ are similar based on these two parallel lines. So maybe I can play with that a bit. So to do so, and also I need to write the ratio of AP divided by PB because that's what I know. But I do know PB divided by PA, so maybe I should divide this by PB. So let's go with that. So 1/2 times AP or PA divided by PB or AB, I would say. It's actually divided by AB because whenever you like compare the AHQ and ABC as a similar triangles, you take the AH divided by AB equals HQ divided by BC. So that is something we kind of need to use. We know that PB divided by PA, this ratio divided by this ratio is A over 1. So I will get PA divided by PB, right? So, but let me write that AP divided by AB. I'm just writing AB instead of just PB because I also know AB and then I can relate AB with this triangle as well. So that's why I need to kind of use AB. And then I cannot change the question. So if I divide out AB, I need to multiply by, so I don't change the question. And then there's a HQ, but at the same time, HQ and BC could be related. So I'm gonna write instead of HQ divided by BC. And then I will multiply this BC so I can get exactly the same thing that I have. So what I did basically, I multiply by AB and BC without really changing our result because that just cancel each other. But now we have two fractions that we can kind of use it, okay? So let's rewrite this a bit better. Okay, so that could be written as like AP over AB times HQ over BC times 1/2 times AB times BC. So like we are told the area of APQ is the half of the area of the ABC, right? So like this was the area of the APQ. So, and this AB times BC, you know, AB is the leg of the right triangle, BC is also, if you multiply those and divide by 2, this is the area of the ABC. And then we are told this is half of this product. So if I name this is like 1, then this has to be 1/2, right? So this has to be 1/2. So only way that will happen if this product is actually 1/2. Okay, so then I can say AP over AB times HQ over BC is equal to 1/2. Okay, so this is something useful because I know that like PB divided by PA is A over 1. If you flip this fraction, you get 1 over A, which is actually this fraction. So you can just say 1 over A times HQ divided by BC is equal to. So I need this fraction somehow. So let me double check. This was actually PB divided by PA. So PB divided by PA is 1. So actually this was AB, so not PB. So the AB is just the total. So that is A plus 1. So 1 over A plus 1 or 1 plus A. Okay. And then HQ divided by BC. You know, this is this leg, and then this is this side. So if you compare this triangle to the larger one, you could say that is equal to AH divided by AB. That's by similar triangle. But I like to relate the right side, so which is why I can go with that piece. So let's continue there. So the ratio of HQ over BC is equal to AQ over AC. And if you are not sure about this, this is just a similarity between AHQ and ABC. I just write the corresponding ratios. The reason why I use that because I like to relate like a QC and AQ with the the given information that I have. I didn't complete this part because I'm going to find this ratio in terms of some variable as well. And I do have QC divided by QA is P. So I'm going to try to use this one to relate this, okay? So HQ divided by BC, but HQ is this guy, and then BC is this guy. Maybe I can just write AQ, AC. AC is just the sum of these two. You know, this ratio was P. So if you were saying that QC, let's say this is P over QA is like P over 1, then AC is just the P plus 1, right? So then I can say this is equal to, maybe I should just rewrite AC as sum of the two things, but let's do that as well. But I do like to get this AC split into these two, and then I like to get that as a fraction. So I'm going to flip this fraction because that will be much helpful. So BC over HQ equals AC over AQ. So instead of AC, I will just write AQ plus QC. So let's go with that. So the AQ plus QC over, so AC. No, AQ. And if you split AQ, so you will get AQ over AQ plus QC over AQ. And then you may skip this problem, this piece, if you are really good with this similar triangle, so we can just get this immediately. And then AQ divided by AQ is 1. And then QC divided by AQ. So QC divided by AQ is just P. So I can just say 1 plus P. So this is much better. So BC divided by HQ is 1 plus 7. But what we had was right here, HQ divided by BC, right? So which is just the reciprocal of this. So if you were to write this as over 1, so then I can replace right there 1 over 1 plus P. And this is equal to 1 over 2. And this is something because we were able to somehow relate those two information in one single equation. So that is progress. So let's see what we can go from there. What we can do from there, right? So if you are like lost somehow so far, pause and go back and kind of digest every single step that we did and then move on after. So we have this relation. This is good. But at the same time, we have to use this one. So maybe we have to read the question what we are given and see how this is going to be useful. And I do know like the A is in between 0 and 1, right? So let's go ahead and write as well. So maybe that will be useful. So this is going to be A. And then we want P, which is QC, divided by QA should be. So the P is going to be lesser than 1/4. But you know, P is at the ratio of two positive numbers because that's the ratio of two sides, cannot be negative. So it has to be all the way to the 0. So that's the range for the P. But the question is, how do we go from there, right? So we like to get the something that we are gonna get as the area will be half. And then, you know, for this area to be half, we have to like satisfy this equation because this is the restriction that we were able to figure, like connect two unknowns that will give us the half of the area. So maybe I should get A and P alone. So in that equation, so if you were like cleaning this mess a bit, so 1 over 1 plus A times 1 over 1 plus P equals 1 over 2. So it's not really nicer. So since there's a product, you can flip both fraction upside down. So that will give us like 1 plus A over 1 times 1 plus P over 1 equals 2. And then 1 plus A is equal to 2 divided by 1 plus P. And if you are confused this one, so you can just go ahead and multiply if you really want to, or just divide by this fraction. So we want to find A alone. So the A should be 2 over 1 plus P minus 1. So minus 1 can be written as like 1 plus P over 1 plus P. So that should give us like 2 minus 1 minus P over 1 plus p. And then 2 minus 1 is 1, so that should be 1 minus p over 1 plus p. Okay, so this is also a good one because we were able to get at least one variable in terms of the other one. But here's a question, here's the observation that you probably did already. You know, this equation was kind of symmetric, meaning that if you replace a and p, if you swap those, you don't really get anything different. You just get the same thing, meaning that if you want to find p alone, you are going to do the exact same step, and then you are going to get q as 1 minus a over 1 plus a. And if you don't believe, you can just go ahead and do the steps on your own and get this one. So we have these two. Why do I need those? Because I like this p to be lesser than or equal to 1/4, right? So this q has to be lesser than or equal to 1/4. But this is depends on the a. So we know a is going to be in between 1 to 0, but is this always really going to give us something that we like, right? So if you choose the p's, because this is what you are allowed, this is the desired interest, so the p has to be lesser than 1/4. So if you plug those endpoints of p, if you plug p in this equation, so that you get a equals 1 minus 0 over 1 plus 0, which is 1. So a could be 1, so if you want to get this p to be 0, but if I choose a, p is 1/4, so you will get 1 minus 1/4 over 1 plus 1/4, which is 3/4 divided by 5/4, which is 3 over 5. So meaning that the a could be corresponding p a. So when the p is in between 0 to 1/4, I mean 1 over 4, then corresponding a's are not in between 0 to 1. So you cannot have everything in this interval. So you could have only in between 3 over 5 to 1 for the a values. So we cannot choose something that is lesser than 3 over 5, because if you choose something lesser than 3 over 5, your your p will not be lesser than 1/4, so which doesn't work for that restriction. So we should take the a in between these two. Okay, this is also nicer, and then I think this is what we included, as 1/4 was. And now the last step is the probability. So if you want to get the area 1/2, you have to choose for a in this interval. So it could be any real number in between 3/5 to 1. So you just need to kind of see the distance between those two numbers just to see the whole interval as a desired outcome. So which is 1 minus 3/5. And then the total outcome, which is where you can choose any range, which is 0 to 1. The distance between 0 to 1 is just 1 unit in the real value. So that's just going to be 1. So that's 2/5 divided by 1. That's 2 over 5. So that is our final answer. So I hope that makes sense. If you do find another way, maybe better than this approach, please let me know, because I couldn't come up with anything else other than this one. So this is one solution at least. Okay, I'll see you in the next video.